almost 12 participants. I think more will join. So I think we can start. So again, I would like to welcome all. I think this is the only course you are doing. You are from EV, like electrical engineering. That means this is the only course, I think, a theory course that you are doing from our department, your own department. All other courses are from like basic sciences and all those things. So I would like to welcome to our department. Okay, it would have been better if I would have welcomed you physically, which we'll do in a 1 month time. But before that, we will start our courses. It's already like 2 weeks late. So you know, like if you see this course in your timetable, there are four lectures, like 4 hours of theory class plus one additional tutorial class. So what is this tutorial class? In tutorial class, whatever we will do, like whatever theoretical concept we will learn, based on that, we will solve numerical problems in the tutorial class. And also, if you have any doubts, that also regarding the numerical problems, that also we will address in that tutorial class. That is on Monday. And if you have any doubts regarding whatever concepts you will study in the class, then and there you can raise your hand, write in the chat, or even you can unmute yourself and raise your concern. Okay. Oh, my others are not joining, but it will have joined. I have a list of 24 students. Okay. Okay. So in this way, we will proceed. Four theory classes of 1 hour each, okay, and one tutorial class of 1 hour each week. Okay, 4 classes. Why? In general, there are 3 hours of teaching of a particular subject in a week. 1 extra hour we are doing to compensate the time that we have already lost, because this session in our college have started from 1st August or like 30th or 31st July. Okay. To compensate for this like 2 weeks period, we have given a 1 hour extra for this. Later, when we will cover this thing, like whatever we have lost, when we will cover, it will be of 3 hours lecture. Okay, 3 hours lecture each week, and 1 hour tutorial. There is also a lab session that is, but lab session not conducting it online. Lab session will be in offline mode. So whenever you will come, then only we will start the lab session for fundamental of electronics, and also you have to compensate like at least 2 lab sessions each week. Okay, in that way we will do. So about this subject, again, many things we have already covered in your +2 level. Okay, we will go a bit into detail into that, but most of the things there is a separate dedicated subject that we will learn in 2nd semester, 3rd semester, 4th semester. Okay, all the units you have, all the units that you are seeing here have a dedicated subject to it. So we will just cover what is necessary, okay, for each and everything. For example, in unit 1, you can see we are starting with circuit analysis. Like whatever we will do next, you have to analyze a closed loop. Okay, there will be many components there, transistors and all those components will be there, and you have to see like how what are the signals that are passing through each and every component. So circuit analysis is very important. Okay, so today we'll start with some introductory concept: circuit elements, passive elements, active elements, different kinds of sources. Okay, then we will first start with DC circuit, and starting with KCL, Kirchhoff's current law, voltage law, nodal, mesh analysis, superposition theorem, and some theorems. Now, network theorems we will do: superposition, Thevenin's Norton theorem, and special application to DC circuits. The AC part will not cover here because you will learn there is separate circuit subject called network analysis. Okay, so there you will go into detail. But here, this network theorems we will learn from the perspective of DC circuits. So 4 network theorems we will do: superposition, Thevenin's, Norton's, maximum power transfer. Okay, there are many other. that we will cover in our network analysis subject that you will learn in your second year. Okay. AC circuit analysis, then we will just start the basics of AC, phasor relation, RLC circuit. In many subjects, we will see these RLC circuits, how they behave with time and everything. Impedance, admittance, phasor diagrams, instantaneous power, different kinds of power, complex, apparent, power factor, all these things we will cover for AC circuit analysis. But this is just the basic introduction. Details we are not going into that. Semiconductor, then using this circuit analysis method, now you have to analyze full circuit. Okay, that will come later. But there are some other components like semiconductor devices that can act as a switch or amplifier. So next part is circuit analysis only, but with special emphasis on some specialized devices. And this is semiconductor devices. So we'll start with introduction, diode, Zener diode, and their application, BJT, different configuration, how it can act as a switch or like amplifier, all those things, NPN, PNP transistors in active mode, DC analysis, BJT as a switch and amplifier, single stage CE amplifier. Then we'll move to JFET, junction field effect transistor, MOSFET, metal oxide semiconductor field effect transistor, their structure, operation, IV characteristics. Again, there is a separate, there are two subjects that only go into the detail of this second unit. The first is the semiconductor devices. Okay, I can teach, I have taught to your seniors basic these semiconductor devices. Okay, there is another subject of analog circuits. Okay, analog circuit uses the like these semiconductor devices into different kinds of circuits. Okay, so both these subjects are very important from your gate perspective. Here we will do this introduction part, a bit of circuit analysis. Am I audible? Someone please let me know, am I audible or not? Hello? Someone, am I audible?
Yes, sir. Yes.
Okay. Okay. Thank you. And then we will move to integrated circuit. Here we will see like operational amplifiers. I think the basics you have done in your class 2, but we will go into the basics, the basic properties of op-amp, why it is so widely used, these characteristics, different kinds of circuits like additive, summing amplifier, inverting, non-inverting. Then we will see 555 timer, how it, what is the basic configuration, what kind of circuits we can like generate using this IC555 timer. Again, the details you will learn in analog circuit subject, but like then the digital part, electronics. Again, a separate subject is that we learn basics like number system, logic gates, logic minimization, Boolean algebra, K-map, truth tables, all these things, combinatorial circuits, and FPG. Okay. GS will be very important throughout your this B course. So please focus on this. And lastly, like we have done circuit analysis first unit, then we have learned about different semiconductor devices that you can use in circuit, different kinds of circuits, integrated circuit, ICs, okay, and digital electronics. Now, the last unit is a application of all these things. Okay, like when you are using your mobile phone, okay, it all these concepts that you will learn till unit 4, an advanced version of all these concepts will be used. And the basic of that, okay, we'll introduce in this introduction to communication engineering. It's the application of all the things that you learned in the first 4 units. Okay, so we'll start with the basic introduction to communication systems, like in block diagram way, means what are the basic components of any communication system, be it the basic one or advanced one. These blocks will always be there. So those blocks will study multiplexing, modulation. Okay, both are like very practical terms. Without multiplexing modulation, you cannot implement any communication system. So communication spectrum, okay, you typically hear in spectrum auction is going on and all this Airtel, all are participating. We will learn about electromagnetic spectrum, what it is, means range, all these things we will see, what is bandwidth concept, that we will learn. Okay. So these are the 5 units, and you can also see on the right hand side the lectures allocated to it. So in 10 lectures, we'll cover the first unit. In 10 lectures will be required to cover the second unit. So in first unit, we can cover using less lectures, but those lectures will be required in the second unit because second unit is bit big. Okay. So it will take I think more lectures than 10. So that we'll cover, we'll take less lectures for the circuit analysis and we will compensate that with this semiconductor devices. Integrated circuit, 6 lectures is okay. In digital electronics, again, 9 lectures. Again, it is very important part unit, so 9 lectures. And introduction to communication engineering, 5. We'll just introduce the basic, that's why 5 lectures. Okay. Uh, so book for the first part, this Sadiku book is important, Fundamentals of Electric Circuit. When we will add, you will get the physical copies from the library. All these physical copies you can get in the library. But till the time you are doing these online classes, if you search the internet, okay, simply if you write on the Google that, okay, fundamental of electric circuit, Sadiku PDF, okay, I think you will get. We cannot formally share those links, but if you search on the internet, you can definitely find. Yeah. So a microelectronic circuit is for the second unit. Yeah, semiconductor devices. Morris Mano digital design. That means the fourth unit. Okay, like digital part. And Boyle said also semiconductor devices and this operational amplifier. Then Boyle said you can find all those things. Okay, so these are very standard books. If you go in any IITs or any standard institutions, these books will be followed. Okay, when we will study your subject, you have to read these books from uh, first word to the last. Okay, in that way you have to that seriously to study these books. Okay, for any exam that will appear for after your 4 years, GATE, ES, any interviews. Okay, fundamentals from these books will be very required. We'll also cover the fundamentals, but definitely covering all the topics is bit difficult. So that's why you have to also work out your own. Definitely will help, but everything means each and every topic from the book cannot be covered. Okay, but each and every most of the topics from these books are very important for your GATE exams. Reference, there are many reference books. If you want, you can consult them, but we will mainly focus on our textbooks. Okay. About the examination pattern. Okay, so in examination, you will have a mid-sem in the month of October. You will have a mid-sem. I don't know. It may change because there's this delay and all those things are there. But most probably in the month of October, you will get. You have to appear for your mid-semester exams. Okay? Mid-semester examination will be of 30 marks. Okay. Then in November, at the start of November, the mid of November, you have to appear for your end semester examination. End semester examination for this subject will be of 60 marks. Okay, so 60 end semester examination, 30 mid semester, so 60 plus 30, 90 marks. And then there will be another 10 marks, which will be based on your attendance. Okay, how good is your attendance in the class? If you're not attending the class, then definitely you will not, you will get less marks out of that. Attendance, then I will give you some assignments. Okay, you have to submit the assignments within time. If you make delay in submitting, some marks will be deducted. Okay, and there will be quizzes. In a semester, there will be at least 2 quiz. Okay, so these 3 things: attendance, assignment, quiz. Based on this, another 10 marks is there. So 60 end semester, 30 mid semester, and 10 marks for that quiz, assignment, and attendance. Okay, so 100 marks. So out of 100, you will get your marks. And the marking will be relative marking. It's not absolute marking. That means if you have got, let us say, means 60, Okay, there is no grade like if you have got marks between 60 and 70, you will get this grade. No, it will be based on how many people have scored that marks. Okay, so someone if you have got like 80 marks, okay, 80 out of 100, and you have got the highest marks in the class, you will get the highest grade, A plus. In that way, it will be relative marking, not absolute marking. Grades, there is A plus, A, B plus B, C plus C. After that, it is fail. Okay, F. F means fail. So these six are there. Six. So this is the basic structure. If you have any doubt in this, like syllabus, examination, and all those things, kindly you can unmute yourself and you can raise those queries. Okay. You can also, if you have some problem with your mic, you can just write in the chat also. I can see.
Sir, these 5 chapters for only mid-sem.
No. These 5 units, these are not chapters. These are unit 1, unit 2, unit 3, unit 4, unit 5. Okay, these are units. So no, this is for the whole semester. Okay, so probably before, let us say, mid semester, we'll cover at least these first 2 units and half of the third unit. Okay, so this 1, 2, and half of third unit will be in your mid semester. In end semester, you have to cover all the syllabus. Okay, definitely, the portions that have been covered in your mid semester, they will carry less importance, but questions will be there. But less number of questions will be there. More focus will be on what will be done after mid semester. Okay, I'm talking about end semester. In end semester, whatever we'll cover till mid semester, they definitely questions will come from that part, but the marks will be less. More emphasis will be given to what we will do after mid semester exams. Okay? In mid semester, only half will be there. Like uh, first, second, and half of third unit will cover in mid semester till mid semester. The first units. Yes. Any more questions? Is it clear? Any more questions regarding the structure? This we will share. Again, if you go to the like website, or if you simply write like curriculum double E syllabus RGIPT, you will get this whole like it has all the subjects and all the syllabus for all the subjects you will learn till your like fourth semester for like 4 years. Okay, so you will simply download. We will also share this. So if there are no more doubts, let me see if someone is writing anything in chat. Sir, is the course for electrical and electronics same for the first year? Yes, but the classes will be classes will be different. Electronics will be like taught by someone else. Electrical or EV, that I will teach. Okay, but like the question paper and everything, those will be common. Okay, but again, marks and everything, that will be like this. For electronics, there will be like separate marks. For electrical, there will be separate like marking system. Okay? But questions will be same. Are reference book better than course book? Definitely not. The course book that are given, those are the best. So means anywhere you go, in any IITs you go, uh, the same books you will find. Yeah. So today we will start with like basic things. We will start with the introductory concepts. Okay? Start with the introductory concepts. So for fundamental of electronics engineering, Okay, we'll start with some introduction. So if I have to talk about electronics, okay, or electrical, so definitely there will be some flow of charges. So I will go to that, but everything starts from a atom. Everything starts from a atom. So what is the atom? So you know that all matter are composed of atoms. So like now what are the basic components? Like you go into detail of physics, there are many things, but we know that there will be a nucleus, okay, and the electrons will be moving around it, and the nucleus will have like basically protons and neutrons. You can go like subatomic particles, but okay, like more detail. But in the nucleus, it will be protons and neutrons mainly, and we are mainly interested in the electrons. What is happening with the electrons? So in neutral state, what will happen? Atoms will have equal number of like electrons and protons. Electrons, you know, carry the negative charge. You also know the amount of charge it carries. It will be important. Protons have a positive charge. Neutrons are like neutral. Okay. The negative charge of the electrons, they are balanced by the positive charge of the protons. Okay. So electrons are bound in the orbit by their, like, again, you know, opposite charges attract each other. So the electrons will be bound in their orbit around the nucleus due to their attraction to the protons. Okay, the positive charge. But for the flow of current or for the flow of electricity, what you need? You need free electrons. Okay. So electrons which are in the outer orbit, the details, like what are the orbits and everything, details you will study in your material science course and also in the semiconductor devices, basics of semiconductor devices. Okay. I may also subject. The basic atomic structure, what are the orbits, what are that you in plus. Still from quantum mechanics, we will learn those in detail. Just starting electronics or this circuit analysis subject from the basic, like flow of electrons, from where the electron is coming. That concept we are just like revising. So electrons that are in the outer band of the atom, that can become free of their orbit by the application of any kind of external force. External force can be like magnetic field, like friction, or any kind of a chemical reaction. Due to these forces, you know that these electrons which are in the outer orbits that can become free. So we mainly by this we refer the free electrons. Okay, so a free electron that leaves the atom, okay, and it creates a void. So that void can be created by atoms from the other atoms, nearby atoms. Okay, so a free electron that leaves a void that can be filled by the electrons which are forced out of the orbit from the other atoms. Okay, as free electron will move from one atom to the next, flow of electron you will get, electron flow you will get. Okay, so that is the flow of electrons, and this is the concept of free electrons. So in the atoms, we are mainly interested in free electrons and why they will become free. What are the outside forces that may you can give that may make these electrons free? That is also important for us. So in atoms, we are mainly interested in free electrons. Then free electrons to move, they need some kind of a like conduct. So a material through which these free electrons can flow, that is the conductor. Electric current is produced when this free electron will move from one atom to the next. Okay, any kind of a material that allows this flow of electrons, that means electrons flowing from one atom to another, this any kind of material that allows this flow will be known as conductor. Okay, example: copper, gold, silver, aluminium are all conductors, but the most popular one is the copper because it is the best conductor and also the least costly, or inexpensive. It's inexpensive compared to gold and silver. Okay, and it is better compared to aluminium in terms of conductor. So these are the examples of conductors. So, but conductors cannot work alone. Outside the conductor, you need a insulator also. So that the electrons that are flowing in the conductor, they may not like move away from the conductor into the other like surrounding. Okay, for that you need a insulator. That means where it will have a like a insulated part. This is the insulation part, and inside there will be the conductor. So insulator is also very required. Any kind of a material that do not allow this flow of electron through them, that is known as a electron. Any kind of plastic, rubber, glass, mica, any kind of ceramic material, those are good insulators. Okay. So in electric cable, you require both conductor and insulator. Okay. So insulator, what it does, it prevents these electrons that are flowing through the conductor. It keeps them inside the conductor. It prevents them from flowing outside. Okay. So these are like any kind of a like electric cable, that is an example that that has both a conductor and an insulator. Then another thing is there, that is the semiconductor. Semiconductor both has conductive properties and insulative properties. It can act as a conductor, it can act as an insulator. That's why you can use the semiconductor as a switch. When the switch is on, that means it is conducting the flow of electrons. When the switch is off, it is acting as an insulator. It is not allowing the flow of electrons. So in semiconductor, it has both the properties of conductor and insulator. You have to select which one you require by giving external forces like external biasing and everything. Based on that, you make this semiconductor work as a conductor or insulator. Okay. Semiconductor, will be going of the semiconductor devices in our unit 2, and there is a separate subject also for this whole semiconductor. Then what about electric charges? So any matter, you have we have discussed that any matter have atoms. So like again, there is a periodic table. There are many elements. So elements are defined by a particular element is defined by number of electrons that are there in the orbit around the nucleus of the atom. Okay, and how many number of protons are there in the nucleus. For example, a hydrogen atom has one electron and one proton. One electron in the orbit and one proton inside the nucleus. And aluminium, if you consider, it has like 13 electrons in the orbit and 13 protons. Okay. So an atom with the equal number of electrons and protons is neutral. The positive charges, negative charges are negating each other. So it is a neutral. Okay. Electrons in the outer band of the atom, they can be displaced. I've already told they can be displaced by some kind of external force. Okay. We'll study about these external forces. But these electrons can be forced out of their orbits and they will create a void. Okay. Void. That void may be filled by the electrons coming from the other atoms. Okay. Nearby atoms. So if if electrons are moving, it may happen there may be a area where there are more electrons. There may be an area there are more protons. Okay, more electrons means more negative charge. More protons means more positive charge. Okay, so a material which have more protons than the electrons has a net positive charge. A material with more electrons than the proton will have a net negative charge. Okay, the positive and negative charges is caused by this excess or absence. More negative charge means excess electrons, and positive charge means excess of protons or absence of electrons. Okay? But as a result, you get these electric charges. Electric charges, you know, Coulomb, the unit is Coulomb. We will go into detail. And when these like electrons are flowing, okay, that means using some external forces, you are moving some electrons out of their orbits and you are creating this void. This void is being filled by the nearby the electrons from the nearby atoms As a result, these electrons you can see are flowing through the, if it's a conductor or semiconductor working as a conductor, it is flowing through that conductor. Okay. So how you can move an electron out of their particular atom? You can apply some voltage. You can apply some positive voltage. If you apply positive voltage, the electrons will be attracted towards the positive voltage. As a result, it will move out of it will move out. Okay. So flow of electrons will be from towards the positive terminal of the battery. Okay. But then current, what is current? Current is again flow of electrons, but by current we mean some positive charge is flowing. So the positive charges will be flowing in the opposite direction. Okay. So if the electrons are flowing in this direction, this is electron that are flowing, then the current I will be flowing in the opposite direction. Okay. Current I will be flowing in the opposite direction. So that is the current flow. So current, you can also know current, the unit is ampere. Okay. And it is also like amount of charges dq by dt per unit time, how many charges. So in this way, you can understand what is current. Again, this is subject or your whole, this 4 years, whatever we will study, these are the basic things that we are discussing. Next concept that we will see, what is voltage. So let sorry so let W joules of energy is required to move a positive from point A to B. If this much amount of energy is required to move a like positive charge Q, then definitely there will be some kind of a potential difference between. This indicates that there is a potential difference between point A and B, okay, or a voltage difference. So what is the potential difference? That can be denoted as V. V is nothing but how much joule of energy is required, W, to move a unit charge. Here, W is required to move Q amount of charges. But what is voltage? Amount of energy that is required to move a unit charge, okay, or 1 coulomb. So what are its? What is the unit of this energy? That is joule. And what is the unit of this charge? That is coulomb. So the unit you can also denote as joule per coulomb. Okay? So this is the voltage. This is the concept of voltage. Okay? This can also be denoted as the work done. Those things will come. So amount of energy required to move a q amount of charges between 2 points. Okay. Then if this much amount of energy is required, what is the like potential difference or voltage difference between these 2 points? Then that will be the amount of energy required divided by the amount of charges that you are transferring from these two in between these 2 points. Okay. Even if you are not moving charges, this concept is valid that what is the potential difference between two points. Okay. It's not like literally you have to move those charges, but this is a basic definition of voltage. So this again will come later, like amount of work done, okay, unit of joule or energy divided by the amount of charges. This concept will again return back. Okay. Next is power. Okay. Again, power is the work done per unit time. Okay. If you are applying, let us say, a field of F newtons, okay, electric field of F newtons that are acting for a duration of t seconds and through a distance of d, then the amount of work done W, that will be equal to the force that you are applying multiplied by the distance. And again, what will be the unit? Meter or joule. So the power will be in unit time. That means the work divided by time. Okay, or the force multiplied by displacement divided by time. Okay, or divided by. Now, can we rewrite this thing? Okay, like there is a. Can we write it is like this? A by B multiplied by B by C. This you can cancel. That will result into A by C. Can we apply this thing here? Say work done divided by charge. Let's say charge is the B part. This B. A is work. C is your time, and we are introducing this B, that is charge, multiplied by charge divided by time. What is work divided by charge? Work divided by charge. This one, voltage. Work divided by charge is nothing but voltage, multiplied by charge divided by time, dq by dt. Amount of charge divided by time, dq by dt. That means current. So power you can also write as V multiplied unit of power, watt. Again, this will using multiple times V. Okay. Throughout your like this journey of studying electronics engineering, these concepts will be coming back repeated. Then, if this is clear, what is power? Then what is energy? So how much power that is consumed in a given amount of time, that will be energy. That means power multiplied by time. So energy is W, let us say W is the energy power, or sorry, power multiplied by time. Power you can rewrite as V multiplied and multiplied by time. Okay, the unit of energy is joule. One. Its unit is joule or power multiplied by time, or you can also write it as watt multiplied by second. Watt second. Now you are consuming again, you are consuming electricity, you are consuming energy. What in your home there are all are consuming some kind of energy. Power multiplied by how much it is running, some energy is being consumed. So there is a and if you have used this many units, then you have to per unit what is the cost, and based on that how many units you have consumed, multiplied by that you will, your electricity bill will be determined. So what is 1 unit that you consume, a household consumes, that is 1 kilowatt hour. Here what you are getting energy is watt second. Okay, and again you have to multiply it by 60 seconds. So that in that way you will get 1 hour. Again, watt multiplied by 1000 you will get kilowatt. Okay, so this is the basic unit of electricity that you consume. So 1 kilowatt hour is a of energy that is used. Okay, while determining your electricity bill and everything. Energy, the basic is watt second, 1 unit of energy that is typically used for determining electricity bill and everything. It is 1 kilowatt hour. 1000 watt, 60 seconds. Yeah. So these are the basic things. We started from atom. We started our discussion from atoms, free electrons. Why the free electrons move? Okay, like if it moves, then flow of current will be there. The materials through which it can flow, conductor, insulator blocks them. Semiconductor can both act as a conductor and insulator. Okay, then the various concepts or units like voltage, power, energy, those things we have covered. Now we'll go into some of the basic circuit elements. Again, circuit elements can be classified into active. There are other ways also other ways to classify circuit elements that we will cover. But the things that we are starting with, we will be active circuit elements and passive circuit elements. We'll see one resistance, learn resistance or L, and capacitance. So resistance in whatever material we are using, okay, all the materials try to oppose this flow of electrons or flow of current. Okay. So if it is a very good conductor, resistance will be very less. Okay. Insulator is also blocking it. It's a high resistance, huge resistance. Okay. So resistance is like a phenomenon by which any material opposes like this flow of electrons, consequently the flow of current. Okay. So what is the resistance of a particular material? That depends on many things. Okay. That depends on the specific material structure, internal structure like resistivity. It may depend of the material, external area of the material. It depends on the temperature T. Sorry, not time T. It is temperature T, or let us write it as T degree centigrade. Okay. So resistivity, length, and cross-sectional area and temperature. All based on all these things, you will get a particular resistance. What is the relationship? Let us say you are considering your okay, we'll come that later. We will discuss that. Let us discuss inductor. Okay. Inductor is the element, and inductance is what it offers to the circuit. So this is resistance. Again, resistance, Ohm's law that we will study. So let us then discuss. We are first discussing the elements. Then we will see what is a circuit. Okay, how you can incorporate these elements in a circuit, that we will discuss later. Inductors or inductance, let us say. So inductors are elements that store energy in an electric field. Sorry, inductor magnetic field. Sorry, capacitor electric field. But inductor is magnetic. What is the unit? What is the unit of inductance? Can anybody answer? What is the unit of inductance? Come on.
Henry.
Henry. What is the, how we will define 1 Henry? Can you define 1 Henry? What does 1 Henry means? 1 H means? What does it mean? Anyone? You can write in the chat. It is like a sentence. What does this 1 Henry means? You can write in the chat also. Which one? 344. Anand, can you, what I have to repeat? Please let me know. So can you please repeat this? What I have to repeat? Please write it. Yes, 1 hour means, sorry, 60 minute, 1 minute and 36 and yes, 1. Rho LA. Okay. Rho is the resistivity. Okay. This one is the resistivity. Again, this is dependent on what material you are using. Different material will have different resistivity. Okay. This L is length of the conductor, length of the material. Okay. Length of the material. A is the area of the cross-sectional area of cross-section. Again, of the material or conductor. This is nothing but the temperature. So R will be R is equal to rho L by A. Okay? Rho L by A. If the length increases, the resistance will increase. Okay. If the cross-sectional area increases, then the resistance will decrease. There is a whole subject, okay, a subject called instrumentation engineering. That also I may teach. I have taught your senior, which will be using this concept of resistance, the basic definition of resistance, R is equal to rho L by A. This concept will be used in detail. Okay. This concept will be used in detail. Chiranjit, joule per ampere square. Have I written it wrong somewhere? Okay. Where? Chiranjit, where? Joule per ampere square. Okay.
Sir,
Yes. Yes, Chiranjit. Chiranjit.
joule by ampere space.
Your voice is not clear. Please repeat.
Sir, 1 Henry is equals to joule by ampere
Okay,
square.
Henry. But there is a particular, like, okay, that is okay. But how you will just articulate it in a sentence? How you can write what is the concept of what is the relation with voltage, what is the relation with current? Everything can be defined in a particular line. That also is important for 1 farad for capacitance. That line is very important. So that we will magnetic flux per unit current. Yes, but again, what is 1 Henry? What is the magnetic flux corresponding to 1 Henry? What is the current corresponding to 1 Henry? That I will write. Okay. So I was talking about resistance rho L by A. There's this whole subject of instrumentation engineering. If you increase the length, reduce the cross-section area, what will happen to the resistance? Okay. Based on this change in the resistance, you can detect what is happening, how much temperature is increasing, decreasing. That you can detect using the change in the resistance. For that, there is a concept. What is the relation with temperature? That the resistance at a particular temperature RT, okay, that will be equal to resistance at a particular reference temperature R0, 1 plus a coefficient, temperature coefficient beta, and the change in temperature T. So this is a basic concept of thermistor and everything. Okay, for thermistor, thermal, um, like thermometer, okay, resistance thermometer, all those things, this concept is used. So the like how resistance is dependent on length, cross sectional area, and resistivity. This how resistance is dependent on temperature. Okay, this we will study in detail in the subject. So 1 Henry. So 1 Henry inductor of 1 Henry. Let me write it. Let me write it in here. An inductor of 1 Henry will result in a 1 volt, result in a 1 volt changing potential difference when a changing of 1 ampere is put into the inductor. So that is like 1 Henry. Inductor of 1 Henry, okay, will result in a 1 volt changing. Again, it will change over time, changing potential difference when you are, the important word here is changing. Okay, changing potential difference, that is changing over time, and changing current. When this 1 ampere changing current is being introduced in an inductor whose value is 1 Henry, it will produce a this potential difference, changing potential difference of 1 volt. Okay, that is the concept of 1 Henry. We'll solve more problems. Uh, we'll derive what is the voltage current relationship between these two things, what is the amount of energy stored in an inductor. This will be very important. Amount of energy stored in an inductor, capacitor, all these things we will cover in our next class, and then we'll move into KCL, KVL, and all these things.
Sir,
Okay. Yes.
sir, explain this once again, sir.
Okay. So inductor, you know, it is like a conductor and it will be like a coil. Okay. Now you are introducing a changing current of 1 ampere. Okay, and this conductor, okay, or coil, it has a like inductance of 1 Henry. Then if this is the case, it will produce a potential difference plus or minus in which polarity, that we will do next. Okay, it will produce a like a potential difference across these two terminals of 1 volt. Okay, how, that we will learn. How this is done, what is the relation between these two things, through mathematical property, these mathematical derivations and everything we will do. Okay, but this is 1 Henry, inductor of value 1 Henry, that will produce a changing 1 volt potential difference when a changing 1 ampere current is introduced in it. Okay, what is there outside these two terminals, that we'll see. Okay, that will be like what kind of a circuit you are using. Okay, based on that. So what is the relation between this current and voltage? Let us say there is a inductor of L, okay, value L. Then what will be the relation between current? Over time, what is the relation between voltage and current? I am talking about the changing part. Actually, what is meaning mathematically, that will start in our next session. Okay? That will start. If you have any doubt, further, if you have doubt, you can ask in the chat, but I have to start taking the attendance, otherwise time will be up. Okay. So I have to start taking the attendance. By that time, whatever your doubts are regarding our course structure, regarding how the classes will be conducted, regarding whatever we have I taught today, please raise those in the chat. Roll number Abdes. Just sir. Okay, I will answer these questions. First, give your attendance. Abdes Jatao. Are you there? Abhijit absent. Abhijit Biswas. Abhijit Biswas, if you are there, you either write something in the chat, yes or you can unmute yourself. Okay, absent. Akash Rai. Akash Rai. Okay, Akash Rai is present. Anag is present. Apurva.
Present, sir.
Arin Agarwal. Present. Darshan Banwal. Darshan.
सर अनक का हो गया?
हाँ हो गया.
थैंक्स.
दर्शन है. Okay, Darshan is not there. Devanshu. Devanshu is not there, absent. Ekans.
Yes, sir.
Ekans. Devanshu, okay. So please change your name. Devanshu, please change your name, otherwise difficult to understand. Okay. Please change your username. Anak, yes, I have marked your attendance. Karthik Goel. Karthik. Absent. Potsamel Latong. No, not there. Absent. Chris Kumar Singh. Chris. Absent. Manisha. Absent. Manja Charanjit, you are present.
Present, sir.
Yes, okay. Manjari Yadav is present. Mayank Sharma.